I am going to talk about Kubernetes for sure, but I want to give you kind of the broader context as well, because Kubernetes alone isn't enough. I think that's the main takeaway that I want you to come out with, is that Kubernetes alone isn't enough and that you need all of these other things around it. Even the chart that Faiz showed really started to give you a sense of that already. What I want to start with today is a story. So we have a customer that has been engaged with us at Pivotal for the last couple of years already. Been very successful with us, have really transformed the way that they've been able to build and deliver and manage their software for a certain set of their workloads. And that theme will come back again and again. And back in December, we were at an event where Faiz asked, and there were a number of you that self-identified as individuals who were either cloud operators or platform teams or more IT personas, more IT infrastructure personas. And that's the scenario. So that team, a team which they had become the platform team, were presenting to their executive leadership at this company. It was a large financial services company. And one of the EVPs in that room at the end of the presentation said this, and I'll only read out what's in the bold, which is, "You are secretly changing the company from the inside." How often has an executive leader in a company said that IT is the thing that's the game changer for them? How often does that happen? Usually it's IT is the trouble. It's the ones that are keeping us from being able to do something. They aren't keeping up with our needs and all of these complaints. But here we had this quote that said, actually, the way that you're doing IT is actually a game changer for us. And that's a pretty significant statement. So why is that? Why was the executive able to look at that and see that? And it was because the team had either described or had even demoed things like doing upgrades during office hours, zero downtime upgrades. So they weren't doing upgrades at 2 in the morning on Saturday and scheduling maintenance windows to do that. They were doing them during the day so that if something went wrong, they had all of the team there that they needed to fix that. And really what this represents is that IT management functions, things like upgrades, become a non-event. The problem today is that it's this big event that we have to schedule maintenance windows for, we have to practice, and we have to do all of these careful things. It's no longer an event for this company. Upgrades are just upgrades, something we do, it's an everyday thing. The other thing that they showed was how you can take things that are currently done in a very manual kind of, for every deployment and every app, we have to go through all of these checks to make sure that security and compliance is met. If instead we bake that deeply inside of the platform so that when we deploy things into the platform, we know that all those requirements are met, those security requirements are met, then that's a game changer. We can deploy our code much more quickly. And then the other thing is patch management. So it's never good to have vulnerabilities, but it's great when we're able to talk about patch management and how well we do when things like Meltdown and Spectre come along, and we can remediate those and show you how you can remediate those in a very, very short amount of time. And I'll talk about that later and give you a perspective of that. And so these are the types of things that are being realized by a real cloud native application platform. Now, when we think about the values that people get from a platform such as this, we typically bucket them into these 4 buckets. And I'm going to come back to this over and over. Developer productivity. And absolutely, developer productivity is super, super important. And when I started working on platform as a service about 6 years ago, I thought it was all about the developer because I come from a developer background. I've been a developer for 30 years. So I thought that it was all about this, the developer productivity. And then I started working with our clients and I realized that the long tail is actually everything else that's on this screen. It's being able to do that do things like those upgrades, the operational efficiency, being able to manage and monitor and those types of things. It's being able to meet the security requirements, and it's just availability. Having a system that is always running for me and my workloads are always running and I get some assistance in doing that, that's really what the platform can provide. So I'll come back to these 4 themes over and over again throughout the next hour or so. Okay, so before I go too much further into the platform, I want to establish some swim lanes. I want to talk about a couple of personas. And in fact, Faiz, when he started, he asked about 2 of the personas that I'm going to talk about here. And I'm going to use this build out that you've surely all seen, which is traditionally way back when, 25 years ago, in IT, when somebody needed to roll out a new app into production, we had to do the whole thing from the ground up. We had to rack and stack hardware, we had to plug in wires, then we had to install operating systems, then we had to install middleware on top of that, and then we could finally get to our applications. And then VMware, about 20 years ago, came along, and they're celebrating their 20-year birthday, their anniversary. So I know it's about 20 years ago, VMware came along and changed all of that at this layer. They virtualized the hardware. And this is a very interesting thing that this conversation's coming back in now that we're talking about Kubernetes again. But they virtualized the hardware, so that process of deploying code into production didn't start with racking and stacking hardware. We had that. We had pools of resources that we could consume from. And then the VMware environment and the hypervisor allowed us to pull from that pool of resources, those hardware resources, and just dispatch virtual machines. And then I stand up my middleware and my application, shortened the time for sure. And then platforms came along like Cloud Foundry, and it allowed us to take that same metaphor and pull it even higher up into the stack. So now the application team doesn't have to do any of this, or when we want to deploy code into production, we don't have to do any of that. It's all taken care of by the platform. And I'll actually give you a demo at the end that shows exactly how easy this is. Now, the reason that I bring up this cloud platform evolution again is that I want to establish the context in which these 2 personas live. A new version of Java is available. There we go. So these 2 personas are the personas I want to talk about. If you build the platform, and our aim and what we've done with the Cloud Foundry platform is we have established a platform where we can actually separate these 2 swim lanes. We can have a platform team that works separately from the application team, and what's really important is that you have the right contract here. That you don't have overlapping concerns, or that if there are concerns that overlap, you project the things out from the lower layers through an API that the app team can just use. Now, let me give you a little bit of an idea of who these personas are. Well, the app teams are the teams that are building the applications for your business. They're the ones that are building applications that are providing value to your business. They're generally consumer-facing applications, or maybe vendor supplier applications, inventory applications, those types of things. It's the applications that run your core business, not the things that you need to do to keep all those applications online, but the applications that run your core business. Now, application developers, they just want freedom, right? They want to be able to just get their job done without the bureaucracy and without the ticketing system. And so they're the cowgirls and the cowboys that just want to go out and do their stuff. But we also have a need for maintaining enterprise gradeness to those applications that are being deployed. We need to make sure that security is there, that compliance is there, that resilience is there. So I like to say these are the cowgirls and the cowboys that are out there building those net new applications and want to push their code into production several times a day. And these are the folks that are keeping the CIOs and the CEOs out of jail and the companies out of the negative headlines. So these are the folks who are making sure that we're enterprise grade, and these are the folks that are building those apps. So I'm going to come back to those personas several times over. Now, what I want to do is talk a little bit about the values for each of those personas. So I'm going to start with the app teams and talk about what their needs are and how a platform can satisfy those needs. And then I'll move down to the people who are keeping everything working well and keeping things kind of sane from that perspective. So for the app teams, I'm clicking the arrow. I'm clicking the wrong arrow, maybe? What happened here? Oh, advancing slides should not be difficult.
You're not using the right platform.
Here we go. A free Keynote update is available. Isn't that great? Okay. There we go. All right. So again, we're going to come back to this. It's not only about developer productivity, because you'll notice on that previous slide that I didn't talk about only the developer. I referred to them as the app team. So the app team is in charge of building and operating their applications in production. So I'm going to pause a moment because I see people taking photos of this slide. We'll make all these slides available as well. Okay, and so as I mentioned at the opening, we have customers that have been extraordinarily successful. They've met all 4 of those requirements and those things that were on the board. And they've done so on a certain set of use cases. They've done it on microservices-based apps, and FI's asked how many people are building microservices, and there were a good number of you. Microservices do not stand alone. They need data services. When you're building a microservice, you're not going to build your own database, hopefully. You're just going to leverage a database to actually provide the persistence for your microservice. You also have some existing applications that maybe aren't too legacy-ish that you can run on a platform. And the platform that I'm talking about here is the platform that we've had in production and we've been working with clients on for about 4 or 5 years. And this is what we now call the PaaS platform. This is the Pivotal Application Platform. You might know it as Pivotal Cloud Foundry. Okay? And I'll show you what this does. Now, this application platform was really all about this. So, how many of you are familiar with this quote? Quite a few of you. Excellent. Here is my code. Run it in the cloud for me. I do not care how. That's what our VP of R&D, Ansi, crafted, a haiku that he crafted to describe really the essence of what the PCF platform and what the PaaS platform is all about. And what that means is that the developer does this, just this. And this extraordinarily complex sequence diagram that I'm not going to go through in detail is everything that the platform does for the developer or for the application operator. They deploy the code, they say, here's my code, run it in the cloud for me. I do not care how, here's the how. Here's everything that we do. So what are some of the things that we do? We do things like we bundle it up into a container for you so that you can just stamp that container out over and over and over again. We then capture that bundled thing. Then we start streaming output. We bind it to data services at the back end. We assign URLs. We give you DNS entries, all of that stuff. We do all of that for you. All of those things that you used to have to do manually. Another thing that we've done in this part of our platform, and our platform is multifaceted. You notice that there was one column and there's lots of room, so I'm going to fill in all of that, is that we at Pivotal, we kind of know Spring, right? So SpringSource was an acquisition that VMware made that came over into Pivotal. So we have the SpringSource, the core SpringSource development community. So we know Spring, and we know that there's an awful lot of Spring and Java out in the enterprise. And so we have taken this platform and really optimized the Java developer experience. Another thing that we've done is we've optimized this platform for microservices. Now, this is not a microservices architecture. This is the old architecture, which is, yeah, we might have built a whole bunch of individual services, but then we bundled them up as one whole thing that was deployed and managed. So it was bundled up as a single thing. And now we're moving to microservices, and it's a fabulous new world. Does your blood pressure go up a little bit from this slide to this slide? It's a lot busier, right? There's a lot of moving pieces here. And now I need to manage all those pieces together. So what we've done in the platform is we've optimized the platform to address that high blood pressure that you get when you look at all these moving components. So, for example, how do you configure hundreds of instances of hundreds of microservices? Well, we have something for that. It's called the config server. Well, when services are being upgraded or you've got some type of a failure and you're bringing up new microservices scattered all over my platform, how does a client of that microservice find where the new one got popped up? Well, we have something for that. It's called service discovery. And now, when, for example, you know that the network is unreliable, so one of the things you're building into your microservices is retries, so that if I go to access another microservice and I don't hear back right away, I can safely retry. Well, retries are really wonderful until you have a network outage and you get a retry storm. And now you've got a whole bunch of queued up retries that when the network comes back, floods your system and you accidentally DDoS yourself. And what do? You need to make sure that there are safeguards in place so that you don't end up DDoSing yourself. Well, we have circuit breakers for that and dashboards for monitoring that. This is all built into the platform because it's optimized for these microservices use cases. Also built into the platform is native Windows support. So this is not through the mono build pack or some kind of emulator of Windows that's running on top of Linux. This is native Windows hosts that you can run your .NET workloads on. So I made the assertion that there's a lot of Java in the enterprise, there's a lot of .NET in the enterprise as well. So this is something that's covered. So all of these features that I talked about here are features that we've had in our application platform, which I promise I'm coming to Kubernetes very, very soon. That whole platform that I talked about has been running in Linux containers for 5 or 6 years. So we've had those containers. We've had a Docker-like implementation in there before we even actually started talking about containers in the industry, because it is a core foundational component of this type of architecture. All right, so we're talking about these microservices, or maybe a little bit transformation of our existing applications, but those applications don't live alone. I already mentioned it. We need things like databases. So that's where another part of this entire platform comes in, is the Pivotal Services Marketplace. Now that marketplace has a number of things in it. We ship these 4 services and a couple of others. These are the data services. We also ship like all of this, the microservices things that I talked about, those are shipped as a service as well. But these are some of the data services that we ship. Relational, non-relational databases, as well as message queuing, RabbitMQ. And we have the ability to do on-demand provisioning of these things, so you can actually on-demand provision a RabbitMQ cluster. So we will do that on your behalf. But it's not only those 4 services that we provide. We have a very rich and broad partner ecosystem. So these are all the partners that we're working with that are bringing their wares into the platform. And so you can see that there's indexing services, search and indexing. I keep finding all the search and indexing, even things like MuleSoft, Tibco. So, bless you. Being able to bring some more of these legacy workloads in there and so on. So app integration. So we've got a whole host of those types of things. Okay? All right. Now, I mentioned that I've been talking a little bit about microservices apps, and I've said some subset of your existing portfolio. It turns out there's an awful lot more work to be done. you have a lot of applications already running in your enterprise that you're running on infrastructure as a service today. And you have come up with your operational practices, and I'm sure you're doing a great job there. But it actually turns out that if we go back to those 4 pillars of value, when we move over to a higher level, higher abstraction in the platform, we can actually do even more for you. So that's what I mean about there's more work to be done. So I talked about these types of workloads. Well, there's other types of workloads. What might those be? Well, things that are already containerized. So is there anyone in the room who has a development group within your organization that has already built pipelines and they're already building Docker images for apps? Not too many, a few. Okay, so you've got a few. So you've already got some containers that need to run somewhere, right? And what we're finding, and I spend a lot of time working with our customers, helping them kind of wrap their arms around this new Kubernetes thing and the platform that we're bringing, is that what we're finding is that these app teams that have embraced Docker today are burdened with creating their own environment to run those Docker images. Whether it be Docker hand-tooled, or they're picking up Kubernetes, or they're using Mesos, or something like that, the app teams themselves are having to deal with platform. And that's typically something that enterprises want to gain some efficiencies by having a centralized group that manages platform. App teams should be working on apps, not managing platforms. So things that are already containerized. Well, what about some other off-the-shelf software? So things like Cassandra or MongoDB or Spark or something like that. Existing off-the-shelf software. Even Oracle. Oracle is starting to release their software in Docker images. So the world is changing. So off-the-shelf software. More of your existing application portfolio. Maybe you don't want to completely refactor your monolithic application because it's only going to be around for another year. There is no value in me retooling that monolithic application into something that can run on a modern platform, in a microservices-based platform, because it's going away. I don't want to spend a moment. I just want to gain a little bit of efficiency in running it for the next little bit. And there's also a category of stateful or cluster type of microservices architectures. And what I mean by that is, a lot of times, most of the microservices we build out there, if you have one instance of that microservice, which you should never have, you need to have redundancy, so you should have at least 2, or you could have 100, but they can come and go as they please. And when and as they please, well, it might be because you're doing an upgrade. So they're going to come and go. But their actual identity is fungible. So when I'm doing a rolling upgrade and I'm taking down instances and bringing up new instances, if it gets a new identity, it gets a new IP address, it gets some new thing, that's okay, because we have got service discovery that's going to help us with it. Well, sometimes we've got, especially this happens in stateful type of clustered applications, where the individual components need to have some sense of fixed identity. So if I'm going to roll this instance of a microservice, when it comes back, it needs to have its same identity, because the other pieces, the other microservices, depend on knowing that identity. So that's something that's important. Or it needs local state. So there are a number of other more modern application architectures that need a little bit more than kind of this, hey, very, very ephemeral and very movable microservices architecture. It's that next set of workloads that our customers, particularly our customers who are having a tremendous amount of success with the workloads that were running in the original Cloud Foundry product, came to us and said, I'm running 10, 20, 30% of my workloads on your platform, and I'm gaining so much efficiency. Can you help me with the rest of these workloads? I want those same 4 pillars for the rest of my workloads. And that's where we said, yeah, we can help you with that. By then, Kubernetes was emerging as something, a real force in the industry, and that's what we're doing with Pivotal Container Service. So Pivotal Container Service, so I want to go back to containers, this notion of containers. So Kubernetes, PKS, is Pivotal Container Service, spelled with a C, abbreviated with a K, because all the cool kids are abbreviating container with a K. I don't know, Kubernetes. This is taken directly off of the Kubernetes website. Application containers. It's a platform that expects you to bring containers. It doesn't do anything for you in creating those containers. It says, bring me your containers and I'll do things with them. So what that means is if we go back to this picture, I need containers. I need to containerize my workloads. That is a non-trivial thing. For those of you who are not already doing this, coming up with containers that have your enterprise controls in them and all of those requirements, making sure that you've got blessed images, making sure that you are keeping track of what is in those images so that you know how to track where the vulnerabilities are and things like that. This is non-trivial. But I'm going to set that aside and say, let's say we've solved that problem. Because Kubernetes doesn't solve that problem for you. It expects containers. Okay, so we've got containers now. And here it is. Here's Kubernetes running your containers. So what you can see here, and I don't know if you can see it in the back, but there's like little dotted lines here. So I've got different nodes, different virtual machines that are running my workloads. And then I've got another virtual machine up here that's the brains of Kubernetes. It's the Kubernetes master. And you can have multiple masters as well. I'm just depicting it with a single master. And multiple worker nodes that are running my workloads. And along with Kubernetes, you also get some interfaces to Kubernetes. You get a CLI, kubectl, and you get the Kubernetes dashboard, which is a UI that allows you to see what's going on in your cluster. That right there is for the app team. This is Kubernetes. This is what you get with Kubernetes. If you go to Kubernetes and you do a git clone and you stand it up from source, this is what you get. But this is not enough, because you'll notice in just a moment that it's missing all sorts of other things that you need to take the Kubernetes open source project and make it a platform. And those things are things like actual compute. So this is just software. Kubernetes is just software. It's not bringing you the machines that you're running on. You need to install this on machines. So you actually need some nodes that some compute nodes that these processes are going to run on. You need storage. So when I am actually storing my database files and things like that, I need a persistent volume that I'm going to store those things on. Kubernetes does nothing for you in terms of networking across these different nodes. It only provides networking within a node. It doesn't do anything about networking across these nodes. So Kubernetes is in itself a distributed system, but it does nothing for you to actually glue those pieces of the distributed system together as soon as you go across nodes. So you need to bring your own networking. You also need to route. So I've got these workloads that are running in here, which is great, but right now nobody can get to them. They're running there, but there's no load balancer that's directing traffic into them. Okay, so you need to bring your own routing tier. All of these workloads that are running here, where did I get them from? I need to store those Docker images someplace. You're probably not going to store them on Docker Hub. Most enterprises shy away from taking their very mission critical stuff for their enterprise and storing it out on Docker Hub with everyone else. They want an enterprise registry where they keep their enterprise images. And then, of course, these workloads here are going to need to connect to external systems. They're going to connect to your Oracle or your SQL Server databases. So you need to be able to connect to those external services. Now, if we start to bring these things in, we're starting to get the things that are needed for a platform. We're starting to get a complete solution. But, of course, I need to manage that platform. And so on the right-hand side, I need the control plane that the platform team is going to use. So remember, I started with the swim lanes, and I said there's an app team that's all about building apps, and a platform team that's providing the platform that allows the app teams to just go ahead and do their work. This right here is PKS. We are doing all of this work for you. We are taking Kubernetes, we're taking core Kubernetes, the latest version of Kubernetes, gluing it together with a whole host of other things, some of which I will talk about and some of which Ed Hobbit will talk about in just a little bit, gluing together all of these things to provide you a complete, comprehensive, holistic Kubernetes-based platform. That's what PKS is. Okay. So I want to get just a little bit more concrete, though, is I want to tell you a little bit more about the specific components that we're bringing together. So PKS is everything that you see in the green box. So it's got core Kubernetes here running. It's running using something called Bosh, and I'm going to go into the Bosh layer in just a little bit. And yeah, I have time. So I'm going to go into the Bosh layer in just a little bit. Bosh is a lifecycle manager for your cluster. So I'll make clear what that means in just a moment. I also mentioned that you needed to bring your own compute and your own storage, and here we are bundling in all of the integrations down to vSphere, as well as down to not only vSAN, but also the vSphere storage APIs. So we're bringing storage in through that as well. Now I mentioned the container registry, and I said you're not going to store things out on Docker Hub. We're also bringing in, bundled as a part of the package, is Harbor. Harbor is an open source project that originated out of VMware. This is the commercially supported version of Harbor. And what it does is it gives you not only a place to store those images, but it also does vulnerability scanning on those images. So when somebody finds out about the latest operating system vulnerability, it can scan through all of the images that are out there and take a look through all of the operating system, file system level stuff that's in the image, and make sure and identify those images that contain that vulnerability. It also has image signing so that somebody can't accidentally or intentionally introduce something into the registry that shouldn't be there. So that's Harbor. And then finally, there's something here that I'm calling the GCP Service Broker. And the GCP Service Broker is really just a placeholder for external services. Remember I said that the workloads that are running in Kubernetes, they're going to need to reach out and leverage some services that aren't running in platform. Well, some of those services, if you're running in an environment where you have access to Google, you might want to reach out to services that are in the Google catalog, like Spanner or TensorFlow or something along those lines. So what we're also doing is we're including in PKS that ability to create, install what are called service brokers that give the developers the ability to, in a very seamless way, access those services on the outside. Now, while I'm mentioning the GCP Service Broker, let me take a moment to make clear that PKS is a three-way collaboration between three companies. Pivotal, you're here with us today. VMware, you're going to hear from Ed later, and we have several VMware colleagues that are in the room as well. And Google. And I'll say more about why Google partnered with us in just a bit, especially when I start to talk about the Bosh layer. The other thing that is here on the left-hand side is, remember I said that as soon as you have a platform, you need to manage that platform. There's a whole host of tools here that come from the VMware, largely from the vRealize suite, that provide you that management and monitoring layer. That allow you to do logging and metrics and those types of things. And Ed will talk about that a little bit more later. All right, so that is kind of in a nutshell what's going on with PKS. Now, I'm going to show you something that is really, there's some stuff that's under the covers with PKS that I'm going to show you more of in just a moment. But just to round out the picture of a holistic platform is that there's even more. In addition to these workloads that we've been talking about, who is starting to think about functions as a service? Ooh, just a couple of you. So the kind of Kleenex name for this, you might know it as AWS Lambda. So Amazon Web Services, like many other things in cloud platforms, were kind of the folks who really brought this to the attention of the industry, is this idea that I write just a teeny tiny amount of code and I tie that to an event, and when that event happens, that's the only time that that code is running. So it's an even more constrained, it's even less code that you provide. Here's my code, run it in the cloud for me. It's even less than what we do in the traditional platform. And that's what we're doing with something called Pivotal Function Service, and that's going to be released later this year. If you're interested in that, we can certainly point you to, we've already announced it, there's an open source project that it's based on that you can get access to today, and that kind of gives you an overall picture. Now you'll notice that across all of these things, we have things like shared logging and metrics and service brokers, like I talked about earlier, security and shared networking. You can see VMware NSX in there. And underneath all of this is something called Bosh. And that platform that I just described, because now it's going to start running a huge part of your workloads, the platform itself is mission critical. So it's important that your applications stay up and running well. But your applications are now, and your business is now depending on that platform. And for all of you that self-identified as kind of the platform operators, this is your heyday. And I'm actually, has anybody been to the DevOps Enterprise Summit? A handful of you. Okay, so it's coming to London again, and if you're going to be there, I'll see you there. I work with Gene. Gene Kim is one of the co-authors of the Phoenix Project, and I work with Gene on the programming committee for that conference. And he and myself and a few other people are working on a special theme around this notion of, for the last 5 or so years, it's all been about the developer. The new kingmaker has been the developer. We believe that the new kingmaker is now the platform team. And we're starting to really look at the stories and the techniques that that new kingmaker is working on. And it's all about keeping the platform itself up and running. So let me talk about that then for the platform team. What are we doing in the box for the platform team? Because all those values that I talked about were for the application developer. It really comes down to this layer here at the bottom. So what we have here is a couple of things that I want to point out. We've got something called Bosh, and I'll explain what Bosh is more as we go through this section of the talk. But the first thing that I want to draw your attention to is this arrow. What this arrow is all about is it says you want to run your platform the same way that your application teams are running their apps. Your application teams have established pipelines for the life cycle of their application development. They've established pipelines that push things from development through staging into production, that automatically execute when you check something into a repository. So they have all of that mechanics worked out at the application tier. But when it comes to platforms, we were still doing an awful lot of stuff ourselves. Yes, we were building scripts, but then you still needed a human being to run that script. You had to know that a new binary was available and say, there's a new binary available. I'll download it from the distribution site, then I'll run my script, and so on. What we have done is, and when I say we, I mean Pivotal has this so deeply ingrained, is we have an API on our distribution mechanism. Pivotal Network is how we distribute our software. There's an API for this. So you can build pipelines that automatically look at the equivalent of your source code repository. It's the place that we distribute our code. And you can kick off pipelines that will automatically take care of your platform, automatically do an upgrade on your staging environment, and run some tests against it. So that same level of automation that we do at the app layer, we want to do at the platform layer. The next thing that I want to draw your attention to is something that's labeled the CPI here. The CPI is the Cloud Provider Interface. This is an abstraction that allows everything above this layer to run against any cloud. We have support in PKS, in the Kubernetes in particular. We have currently are supporting vSphere and Google Cloud. We have support for AWS coming next, and Azure and OpenStack are coming as well. So it's a multi-cloud solution. Now that said, 70% of our customers run on vSphere. So there's a huge percentage running on vSphere. The other thing that Bosh does is, so it interfaces down to the infrastructure. The other thing that Bosh does is it manages up to these clusters. And let me explain how that works. Now, these clusters, each one of these clusters up here is a distributed system. It's running as multiple virtual machines. The most involved one is Pivotal Application Service. It runs about a dozen or so different components. It runs the brains of the operation. It runs a scheduler. It runs a health monitor. It runs a logging system, etc. So there's a whole host of services, and you saw all the different services. It runs a staging service. It runs a whole host of different services in here that are running on virtual machines. I showed you what the Kubernetes cluster looks like. I'm running masters and workers and an etcd. So I've got these complex distributed systems up here that I'm running. What Bosh does is Bosh takes care of that for you. It's an intelligent, autonomous system that cares for your platform. What I mean by that is this. And I'm going to show you a demo of this very quickly at the very end, which is one of the core things that has made Kubernetes as wildly successful and popular as it is that Kubernetes has a core cloud principle based into it. And that is, things are always changing. So the core way that Kubernetes works is it never expects you to be finished. When you've deployed a workload out into Kubernetes, Kubernetes expects it to be disrupted. So when you deploy your application, you say, hey, I want 3 instances of my front end, I want 5 instances of my middle tier, and I want my database at the back end. And you tell Kubernetes, I want 3 and 5 and 1. And Kubernetes says, great, I'll take it from here. And if something happens, one of your machines goes belly up, and all of a sudden you're only running 1 instance at the front end and 2 instances of your middle tier, Kubernetes says, uh-oh, you wanted 3, 5, and 1, and I see 1, 2, and 1. I've got to do something about that. And Kubernetes will fix it for you. It'll say, I need 2 more of the front end, and I need 3 more of the middle tier, and it takes care of that. That is a core foundational construct of the cloud, is that things are constantly changing. And so that's what's made Kubernetes really popular. That same pattern of declarative state, you declare your state and this intelligent autonomous system keeps that actual state in alignment with that, is the same thing that is built into Bosh. So let me tell you where Bosh comes from. Who's heard of Borg? Okay, most of you. Google Borg, right? So Google is now running over 2 million servers in production, hardware servers, 2 million hardware servers in production. Some people think that Kubernetes is an open sourcing of Borg. It is not. It is an open sourcing of the container orchestration layer. Beneath that is Borg, which is managing all of the virtual machines that are across these 2 million physical servers. So Borg is something that manages distributed virtual machine-based clusters. Well, Bosh, which is something that was originated out of VMware and now is part of Pivotal, Bosh was originally built by 3 engineers that worked on Borg. And the way that engineers are, they try to be really clever with their names. What they did was they took the name Borg and they added 1 to R and added 1 to G and got Bosh. So they think of it as Borg++. So these are engineers that worked on Borg that came over to VMware and said, if we were to build Borg all over again, what would we do different? And what they did was they built Bosh. So Bosh is, and let me be clear, not taking Borg code and open sourcing it, but it is the closest thing to an open source equivalent of Borg. I told you, I promised you that I would explain why Google was partnering with Pivotal and VMware on this. When we approached Google and said, hey, we're thinking about doing Kubernetes on Bosh, they said, we're in. Because you know what runs GKE? GKE is Google's in the cloud offering of Kubernetes. You know what orchestrates the Kubernetes clusters? It's Borg. So we said, we want to do this for the enterprise. Do you want to partner with us? And they said yes, because they know that in order to do this, you need a layer like Bosh. So again, what Bosh does is, and I can't remember if I have the slide, I don't think I do, but remember that pattern that I talked about? Kubernetes keeps your stuff running the way you want it. Bosh keeps your Kubernetes cluster running the way that you want. So if something goes wrong with the Kubernetes cluster or you're upgrading the Kubernetes cluster, Borg is the lifecycle management for that. Okay? I already talked about multi-cloud. All right, so what can be happening to your cluster? Good, I'm just about on time. So what kind of changes might happen to your Kubernetes cluster? So I'm sorry, I totally forgot to put the quote. What I like to say is that PKS does for your Kubernetes what Kubernetes does for your workloads. PKS takes care of your Kubernetes cluster the same way that Kubernetes takes care of the workloads that are running in your cluster. That's pretty huge. All right, so what are some of the things that then Bosh will do for you? It allows you to do zero downtime upgrades. So you can, for example, when we release a new version up here, it is smart enough to say, I'm going to do a rolling upgrade. I have 5 workers, I have 3 master nodes and I have 15 worker nodes that are running my workloads. I'm going to roll through them 2 at a time so that you have zero downtime. I'm going to drain away the traffic. I'm going to restart things over on these other nodes. Then I'm going to upgrade the next node. Okay, so all of that stuff. And so I'm going to take just a moment to mention all of these things that I'm talking about have all these little fireworks that are going off in my head. A little commercial, please forgive me. I'm writing a book called Cloud Native with Manning. And when I say rolling upgrade, there are all sorts of interesting complexities that you need to think about when you write your software to enable it to have a rolling upgrade. Because during a rolling upgrade, sorry, this is the teacher in me coming out. During a rolling upgrade, you're going to have some instances of your workloads running on version 1 and some running on version 2. And if you cannot have those versions running side by side, then you have to do a blue-green deployment. Then you have to do an all or nothing deployment. So those are all the patterns that you have to look at, and I go through those in excruciating detail in my book. So if you're interested, I'll be around for a while and I can tell you a little bit more about and point you to the book that I'm writing. All right, so rolling upgrades are one. The other thing is that security-related upgrades kind of have their own category, and I call this patch management. And so I want to show you a picture here, and one of the really great things that I would recommend that you look at is look for the 3 R's. If you just Google 3 R's in Pivotal, you'll find a really great description of what we call repair, repave, and rotate that will tell you a lot more about the security posture that we've built into these applications. But let me show you one picture that kind of gives you an idea of what I'm talking about. In a containerized world, what we have is we have our workloads running in containers. So that's this dotted line, okay? Now that container has to run on a host that has an OS kernel. We embed an OS in our platform. PKS has an embedded OS. What we also have in the PaaS part of the platform here is that we also take care of the root file system that's in the container and the runtime layer, so like the JDK, for example. So all of that is platform provided. So this is here is my code. App Team only provides that pink layer at the top. What this allows us to do is it allows us to repair and repave. In other words, a vulnerability happens anywhere in any of these layers, and it allows us, as a part of the platform team, it allows the platform team to remediate that without having to go out to the application team. Extraordinarily powerful. Huge security gain in this particular platform. Now, for clarity, Kubernetes, remember I said Kubernetes expects that you bring this entire thing yourself. What that means is that if you bring your own container, you have to deal with any security posture in here. But here's the beautiful thing. It still comes with an embedded OS. PKS comes with an embedded OS. Spectre and Meltdown, as you know, are hardware vulnerabilities, but they were remediated, at least temporarily, because you can't just do a rolling upgrade on your hardware, right? That's a little harder to upgrade. Software is a little bit more fungible. So the remediation for this hardware vulnerability was built into the kernel, the operating system kernel. What we are able to do in PKS is we are able to roll out, for your Kubernetes distribution, are able to remediate the Meltdown and the Spectre vulnerabilities in a matter of hours. And we will distribute a link to a blog post that we did. We did that on our own version of Pivotal Web Service. When the patch for Meltdown came out, 16 hours. And we had tens of thousands of app instances and hundreds of VMs patched and remediated. Meltdown was gone in the infrastructure. 16 hours. When I talk to customers, they admit that it takes them months sometimes to do that. All right, so taking us back to those 4 pillars, you can see that here a lot of the manageability, resilience, and security comes from this Bosh layer that's in between. Now I'm going to close with just this one statement, and then I'm going to show you one really quick demo. And that is, just a couple of weeks ago, one of the customers that I'm working with is a major US telco provider. And I was speaking with the leadership there, and what he said to me was, I want to move everything to containers because I don't want to have to worry about patching operating systems anymore. In the same way that 15 years ago, I was moving everything from P to V, from physical to virtual, because doing so gave me all sorts of benefits. Today, I am embarking on moving everything I have from V to C. 15 years ago, most of your application portfolio was running on physical hardware. Today, probably 80% of it is running on virtual. This is what we're looking at. This is what we're looking at with platforms such as Kubernetes, container-based platforms, even like PAS, is this ability to move everything from virtual into containers and realize these additional benefits. That's what we're doing at Pivotal together with our partners VMware and Google. All right, so I want to show you one demo. This picture is going to show you 2 demos. I'm not going to do the deploy because I'm out of time. But I want to show you what a zero downtime upgrade looks like in Kubernetes. Most of you didn't identify as being very far along your Kubernetes journey. So I want to show you the coolness that Kubernetes does with the zero downtime rolling upgrade. And to give you an idea of the way that, I think that's good. I'm just going to go over to the demo. All right, let me come here. Let me make this a little bit bigger. Okay, the important side is this one on the right. And what I have here, there we go. Can everybody see that? That good? Let me me just go a couple more. Okay, what I have here is that I have 10 instances of this posts service running. And they're all running well. You can see they're all running. You can see that a couple of them have had some restarts, but they're all up and running. What I want to do is I want to upgrade this. So in order to upgrade this, I'm going to go to my, and you don't have to worry about reading this, I'm going to bump a version number. So I've just bumped a version number there, and now I'm going to execute a single command. kubectl apply, and don't worry too much about the details. Basically what I'm doing is I'm saying, kubectl, I want you to take a look at my manifest. Remember I said that it's all about declaring my state? In that manifest where I just bumped the version number, I said I want 10 instances of this running. So I'm basically saying, hey Kubernetes, go back and look at my deployment manifest again and see if there's any work that you need to do. Now watch carefully because it goes really fast. Rolling upgrade. I'm going to hit enter. The demo gods are smiling on me. All right, you can see some of them are still running, some of them are terminating, there's new ones getting created, more are terminating, there's always something running, and here, pretty quickly, we're going to get to the point where, uh-oh. Did I change something in my manifest? Because all of a sudden it says that there's only 2 instances. Oh, you know what I did? This is actually brilliant. It did exactly what I asked. Because I pointed to the wrong manifest. I pointed to a manifest that only had 2 instances running. Let me change this. I'm going to point back to the manifest, GCP, and watch what happens. Boom. It's creating those others. So I pointed to the wrong manifest. I pointed to a manifest that only had 2 instances. So as a part of the rolling upgrade, it actually tore down a number of instances and didn't bring them back up. But what I just did here was I pointed back at the right manifest, which had the 10 instances, and it spun those up. So with a single command, I didn't have to orchestrate that rolling upgrade. That is a lifecycle operation that is built into Kubernetes. You just say, please do a rolling upgrade. That is a lifecycle operation that is built into Bosh. Please upgrade my Kubernetes cluster and do it in a rolling upgrade. Same exact pattern that allows you to roll through this. All right, with that, I am going to, again, thank you for your attention so far, and we will continue on with the program and start to drill into some of the details. Thank you so much.